Have you ever driven on a highway and wondered, how exactly was this road built? I mean, we use roads every day, but most of us don't really think about what goes into making them. It's not as simple as just laying down some asphalt and calling it a day. There's actually a whole process behind it. A good road has to handle millions of cars, survive heavy rain, extreme heat, and sometimes even snow. And if it's not built right, well, you get cracks, potholes, and a rough driving experience in just a few years. But have you ever noticed that some roads stay smooth for decades, while others start falling apart way too soon? So what's the secret? What makes a road strong and long-lasting? It all starts way before construction even begins. Engineers don't just pick a spot and start paving. First, they have to plan everything, things like traffic flow, the type of soil underneath, and even how rainwater will drain off the road. Because if they get it wrong, that road won't last very long, and that's just step one. Once construction starts, the real work begins. The land has to be cleared, a solid foundation has to be built, and every layer of the road has to be carefully placed so it can handle the weight of trucks and cars for years to come. So today, we're breaking it all down. How roads are built from start to finish. And trust me, it's a lot more interesting than you might think. Let's start with the very first step, the planning and design phase. Alright, so before any actual construction starts, there's one crucial step that most people don't think about: planning and design. You can't just grab some machines and start paving. If a road isn't designed properly, it won't last. First, engineers need to decide where the road will go. This isn't as simple as drawing a straight line on a map. They have to think about traffic flow, existing buildings, hills, rivers, basically everything that could affect the road's placement. To figure all this out, they start with a site survey. This is where engineers use tools like GPS, drones, and ground-penetrating radar to map out the land. They check the soil type, measure the elevation, and even study underground water levels. Why? Because if the soil is too soft or unstable, the road could sink or crack over time. Let's say they find weak soil. What happens then? Well, they might have to reinforce the ground by replacing the soft soil with stronger materials or designing a special foundation to support the road. Once they've studied the land, the next step is creating a detailed blueprint of the road. This includes the number of lanes where intersections will be and how drainage systems will be placed to prevent flooding. Engineers also have to think about future traffic. If they're building a highway today, they don't just design it for today's cars. They plan for the next 20 to 50 years. That's why some highways have space for additional lanes, even if they aren't used right away. Another big decision: what materials to use. Roads are usually built with either asphalt or concrete, but which one is better? Asphalt is more flexible and easier to repair, which is why most highways use it, but concrete is stronger and lasts longer, so you'll often see it in places with heavy truck traffic like ports and industrial areas. The choice depends on cost, weather conditions, and how much traffic the road will handle. Once everything is planned, the design has to be approved by local authorities. They check things like environmental impact, safety regulations, and overall cost. After approval, construction crews get ready to start the real work, building the road itself. And that's where the heavy machinery comes in. In the next part, we'll break down the actual construction process, step by step. From clearing the land to laying the final road surface, this is where things really start to take shape. Alright, now that the planning is done, it's time to get our hands dirty. Road construction begins. This is where massive machines come in, and the land starts transforming into a real road. The first thing workers do is clear the area. If there are trees, rocks, or even old roads in the way, they have to be removed. Bulldozers and excavators are used to level the ground and create a clear path for the new road. But it's not just about removing obstacles. Engineers have to make sure the land is stable. If there are soft spots or uneven areas, they'll need to reinforce the ground before moving forward. Next, the land is carefully graded, which means making sure the surface is smooth and at the right angle. Roads aren't always perfectly flat. They often have slight slopes to help rainwater drain properly. If the soil is too weak, workers will dig it out and replace it with stronger material. In some cases, roads are built over layers of compacted sand or crushed stone to create a firm foundation. Now comes one of the most important steps, creating the base layers. Roads aren't just a single layer of asphalt or concrete. They're made up of multiple layers that work together to handle weight and pressure. First, workers lay down a thick base of crushed stone or gravel. This helps distribute the weight of vehicles evenly and prevents the road from sinking or cracking. On top of this, a finer layer of crushed stone is added, which is then compacted using heavy rollers. This makes sure the surface is solid and ready for the next step. Now comes the part we all recognize: the road surface. Depending on the project, engineers will use either asphalt or concrete. For asphalt roads, the material is heated until it becomes soft, then spread evenly over the surface. Giant rollers press it down, making it smooth and durable. For concrete roads, workers pour a thick mixture of cement, sand, and gravel, which is then leveled and left to harden. Concrete roads take longer to set, but they last much longer than asphalt. Once the main surface is in place, it needs time to cure. This is where the material fully hardens and becomes strong enough to handle heavy traffic. During this time, workers check for any imperfections and smooth out any rough spots to ensure a perfect driving surface. At this point, the road is almost complete, but before traffic can start using it, there are still a few final touches left to do. In the next part, we'll look at the finishing steps: road markings, drainage, and long-term maintenance. At this point, the road is almost complete. The surface is paved, the foundation is solid, and everything looks ready. But there are still some crucial finishing touches that make a road safe and long-lasting. One of the first things you'll notice on a newly built road is the lane markings. These lines guide drivers and keep traffic organized. Workers use special machines to paint lane dividers, pedestrian crossings, and turning arrows. But these aren't just ordinary paint lines. Many roads use thermoplastic paint, which lasts longer and reflects light at night to improve visibility. Along with markings, engineers install traffic signs, guardrails, and barriers to make sure the road is safe for all vehicles. Now here's something most people don't think about. What happens to rainwater on the road? Without proper drainage, water can pool on the surface, making the road slippery and even causing damage over time. To prevent this, engineers design roads with a slight slope so that water flows to the sides. Before any cars can drive on it, the road must pass quality testing. Engineers check for any weak spots, cracks, or uneven surfaces. If something isn't right, workers fix it before opening the road to the public. So now you know, building a road isn't just about pouring asphalt and hoping for the best. It takes careful planning, strong foundations, high-quality materials, and constant maintenance to keep roads smooth and safe. Next time you're driving on a highway, think about the work that went into making your journey possible. If you enjoyed this breakdown of road construction, don't forget to like, subscribe, and follow for more amazing engineering facts.